Now, after obtaining the psi unity of the surface tension, now we can conclude by saying that the coefficient of the surface tension is the force per unit at the length of an imaginary line segment drawn in any direction on the free surface. Kwa sasa baada ya kuangalia ile psi unit, ile formula pamoja na psi unit ya ile surface tension, sasa tunaweza tukahitimisha kwa kusema kuwa yule coefficient of the surface tension atakuwa ni sawasawa na ile force per unit length, sawasawa na force per unit length of an imaginary line segment drawn in any direction of the free surface. So the line of action of the force being on the surface and at right angle to the imaginary line segment. So my dear student, a line of action, we look about the line of action. Line of action tunaongelea kuhusu ile surface pamoja na right angles to the imaginary line segment. Hapo tunaenda kuangalia kale ka angle ambao kanabini formed between the line segment. Tutaongelea kuhusu line action of the force. So surface tension in terms of the surface energy. Let us look for the surface tension in terms of that in terms of the surface energy. How can we how can we define this surface tension in terms of the surface energy here? So surface tension can be understood as the surface energy. Sometimes we say the surface tension is like the surface energy. Kwa ukiambiwa kudefine surface energy, definition yake inafanana ile ya surface tension. Ndio maana nakwambia kwamba tunatakiwa tuelewe kuwa surface tension is similar with that of the surface energy. So molecule on a liquid surface have a higher energy than those inside because they have a fair neighboring. The molecule on a liquid surface have a higher energy. Any molecule, the molecule, my dear student, as we seen that the molecule that are found inside the liquid have a higher energy compared with have a higher energy inside, have the higher energy compared with the neighbor. Kwa ile liquid ambao any liquid inakuwa na contain higher energy inside. Kwa tunapokuwa na drops yetu na tone letu labda la kimiminika fulani, kwa wale molecule waliomo humo ndani wanakuwa wana surface tension, wana surface energy au surface tension ambao ni kubwa zaidi ukilinganisha na pale kwa nje. Kwa nini tunasema hivyo? Kwa sababu ya ile interaction ni kubwa sana. So increasing the surface area require the work. In order to increase the surface area, we are supposed to apply the work. As we know that when we talk about the work, this is the force times the distance. So in order to increase this surface area, we are supposed to provide the work, to have the work, which is stored as the potential energy in the surface molecule. And also work, my dear student, is stored as the potential energy of the surface molecule. Kwa ile inabidi stored as the potential energy. Kwa sasa hapa we can conclude by saying that inside the liquid molecule, inside the liquid molecule there is the higher energy compared with the outside of that liquid molecule. Why we say that? This is because of the higher interaction between the neighboring molecule. And after that, we should conclude by saying that in order to increase the surface area, we are supposed to have the work done. We are supposed to have the work done which could store the potential energy of in the surface molecule here. So the work done against the force of the surface tension is to increase the unit area at the constant surface area. It's called the surface energy. Kwa surface energy sasa tutaidefine kwa kusema kwamba this must be equal to the work done in increasing the surface area then we divide by the increase in the surface area as we seen here. Kwa definition au formula ya kuweza kucalculate the surface energy of the liquid which can be represented by this symbol as we see here. It must be equals to the work done. Kwa lazima mathematical sasa tuta express ile tutaweza kuexpress yule tutaweza express huyu surface energy of the liquid kwa kuchukua the work done in increasing the surface, then we divide by the increase in the surface area. Kwa hiyo ndo formula ambayo tutaweza kuitumia kuweza kucalculate the surface energy of the liquid kwa kuchukua work done ya ile increasing of the surface area, then we divide by the increasing of the surface area. So surface energy also called the free surface energy. Because sometimes this surface energy is called the free surface energy. Kwa jina lingine ukiambiwa kwa sababu terms hizi wanakuwa wanaleta kudefine kwamba explain the surface energy. Kwa wewe ushakalili surface energy, lakini anaweza kukubadilishia pale instead of asking the surface energy could ask you to define the free surface energy. Kwa free surface energy ni sawa na ile surface energy of the liquid which has the sign as that on the surface tension. Both of these are free surface energy and also surface energy and also this surface energy having the same sign with the surface tension which is Newton per meter. Kwa zote zile zinakuwa zina contain the same surface energy the same sign ambayo tunaita ni Newton per meter au tunaita ni Joule per meter square. This is the sign of the surface energy or the free surface energy. So consider the stretching film of the liquid on the horizontal frame. So let us consider that let us assume we have this stretching film of the liquid on the horizontal frame. Tuna horizontal frame na pale kwenye horizontal frame kuna stretched film as we have been told my dear student. Since the film has both an upper and also the lower surface energy. Now the force F on AB due to the surface energy is given like this one. So we get the surface energy must be equals to we get the force. The force must be equal for both upper. Yani tunapokuwa tunaongelea kuna upper pamoja na lower surface. We obtain the force which is equal to 2 times L times the surface tension. Hii ikiwa na maana gani? Ikiwa inamaanisha kwamba itumpate surface tension ambayo ni sawa na force per unit length. Yule length atakuwa ni mara mbili. Timisi tuangalia kwenye upper part pamoja na kwenye down part. Kwa tukimake the subject ile force tutapata kumbe force ni sawa na 2L azidisha kwa surface tension. If AB is moved at the distance x of A dash B dash, then work has done against this force. Sasa ikitokea huyu AB amebini moved at the distance x to A dash B. Now we should obtain this work against the force as we are going to see here. So the surface tension is independent of the surface area. Kwa yule surface tension anakuwa hategemei ile surface area of the film because the size of the surface area increase more molecule inter if and so by doing so maintaining the average molecule as we seen here. So however surface tension increase with increasing in temperature. Kwa yule surface tension tumesema ni independent of the surface area. Kwa nini tunasema ni independent of the surface area? It means kwamba hategemei surface area yoyote yule nani. Kwa sasa tutakonclude kwa kumbe yule surface area tension anapungua pale ile temperature inapokuwa inaongezeka kwa sababu decrease in the binding energy because of the decrease of that binding energy that provide AB is moved in isosceles to AB dash. Kwa sasa ata experience kuwa huyu AB atabini moved isosomally. It means isosomally, anapokuwa na move ana release energy to the surrounding. The force on AB will be constant and the work done must be equal to 2x surface tension times L. Kwa hiyo sasa ili tuweze kupata work done, tutamchukua yule 2 alafu tutamzidisha na huyu kale ka distance from the A dash B dash, alafu tutazidisha na surface tension, tutazidisha na ile length ambayo tutakuwa tumeshapewa. So the increase in surface area is this one. So the increase in surface area must be equals to 2LX. Kwa atakuwa ni sawa na 2LX. Therefore we should come and say that the surface tension huyu atakuwa ni sawa na yule work done ambao tulikuwa tumepewa ni sawa na 2LX surface tension, then we divide by the surface area ambao ni 2LX. Mwisho wa siku tutashow kuwa kumbe huyu surface tension huyu surface energy this surface energy or free surface energy must be equal to the surface tension. Ndio maana tukasema ana the same as a unit, na hapo akakwambia kwamba we could conclude by saying that the surface tension must be equals to the surface area or to the free surface area. So work done, my dear student, must be equals to the surface tension with times by this change of the area, where this is proportional to the constant which is the surface tension. Kwa huyu hapa tunamuona huyu work done anakuwa ni proportion to the constant of the surface tension. Kwa we can conclude by saying that surface tension must be equals to the surface area, must be this work done must be equals to the surface tension, then we times it by the change of the area. So by saying that this will be the end of our session here. Now I would like to invite you again for another session. I wish you all the best. Have a nice moment.